Hey class, I'm going to introduce something called a discriminant. If you recall, our quadratic formula is going to take any quadratic equation, so anything with an x squared, and it's going to give us any solutions. We use that to solve our quadratic equations. It's one method. But within our quadratic formula, we have something called the discriminant, and that's the radicand, which is under the square root. So our discriminant is equal to b squared minus 4ac. And the nice thing about our discriminant is it's going to tell us how many roots or how many solutions we're going to have. We'll either have 0, 1, or 2 solutions. So here's kind of a little chart for what the discriminant tells us. Remember, the discriminant can only be used for quadratic equations, so ax squared plus bx plus c. And then here's your 3 different scenarios. If your discriminant is greater than 0, that means it's any positive number, you will be guaranteed to have 2 roots. Okay, 2 roots means that you have 2 x-intercepts. So your parabola would look potentially something like this. Okay, it's going to cross over that x-axis 2 times. The parabola could also be pointing up as well. Okay, if your discriminant is equal to 0, you're going to have 1 root, but that root will have multiplicity 2. Okay, 1 root means 1 x-intercept, so it could look something like this. And then if your discriminant is a negative number or it's less than 0, you won't have any real roots. We have what we call an imaginary root that we haven't talked about yet, but you also will not have any x-intercepts. So your parabola will not cross your x-axis ever. So let's look at a couple just examples. We're going to ask ourselves, how many roots does this quadratic have? Well, first of all, I need to put it in standard form. So I subtract my 20x to the left side so that I set it equal to 0. And now I can do that b squared minus 4ac. So I plug my numbers in. I get 400 minus 400. That obviously equals 0, so I'm going to have exactly 1 real root. Okay. Here's another one. Plug it into your discriminant, b squared minus 4ac. You get 49 plus 792. I'm not really worried about what that equals, but I know that it's a positive number, right? 49 plus 792 is definitely greater than 0, so we know we have 2 roots for this quadratic. So we're going to use that discriminant as kind of a cheat or a helpful hint to help us find more polynomial roots. So we're going to now solve equations that are to higher degrees. So we're going to have an x cubed minus 27. Well, this is a difference of 2 cubes, which we've solved before, factored before, so we're going to now solve that. First step is to factor. Remember this equation, that's what we're going to have to use. So that factors to be x minus 3 times x squared plus 3x plus 9. And here's where we're going to use our discriminant. So this is a quadratic formula that we're going to use our discriminant to see if we have any roots. If we do have roots, then we can use our full quadratic formula to find those roots. But if it comes out to be a negative number, we know we don't have any roots for that particular section. So I went ahead and solved this first piece to find that root. Remember, in order to solve, you set each of these pieces equal to 0. Well, x minus 3 equal to 0 would give us x equals 3 as the root. And then, like I said, we're going to use the discriminant to solve this x squared part. So our b squared minus 4ac comes out to be 9 minus 36. Again, I don't care what the number itself is, but I know that 9 minus 36 is going to be less than 0. So that means we have 0 real roots. So our only root for this problem would be x equals 3. Let's look at another example. Here are the roots of x cubed plus 64. So I factored it. Again, this x squared part, we can use our discriminant. 4 squared minus 4 times 1 times 16 gives us 16 minus 64. Again, a negative number, so we don't have any real roots for this section. But for this x plus 4, I can go ahead and state that x equals negative 4 would be a root. So we're solving equations like we have before, but this time we're going to check with our discriminant to see whether our quadratic has any roots or not. Okay, here's another. Obviously, this is not a sum or a difference of 2 cubes, so we're going to have to figure out another way to solve this. So we can factor by grouping. So I went ahead and put it in parentheses. Remember, because of this minus sign, when we put parentheses, we have to change our sign because we would distribute. So to keep our problem correct, we change that back sign. So you can take an x squared out of the first piece, and you can't factor anything out of the second piece, but that leaves us with an x plus 2 in each term now. So we go ahead and factor that x plus 2 out, and that leaves us with x squared minus 1. Well, lucky us, x squared minus 1 factors again to be x plus 1 and x minus 1. So this time we will have 3 different roots. We will have x equals -2, x equals -1, and x equals +1 as our 3 roots. Notice we have 3 roots, and that correlates to our highest power. We will never have more than what that highest power is, or we will never have more roots than our degree. We're not guaranteed to have 3, as we haven't in the last 2 examples, but 3 is the maximum number of roots we could potentially have. Okay, we'll look at one more. Again, factor by grouping. When we put our parentheses in there, switch that back sign, and now factor out what you can. So we have an x cubed out of the first piece and an 8 out of the second. Now we factor out that x minus 1, leaving us with x cubed minus 8. This is a difference of 2 cubes, so we factor it as such. This will give us 2 different roots. We'll get x equals 1 and x equals 2. We use our discriminant to decide whether this has any roots. We get a negative number, so our only roots would be x equals 1 and x equals 2.